As part of the reKnowledge Enterprise Suite, we help our clients integrate their data into reKnowledge. This enables them to investigate those data in the analytical workbench and interact with them online with our web browser add-on. To illustrate how you can find insight faster by integrating your data into reKnowledge, we will use the recent FinCEN Files investigation by BuzzFeed and the ICIG. As part of the investigative dossier, the ICIG had made available a sample of the transaction data for researchers to use. The data come in the form of an Excel spreadsheet. Each row is a transaction with the following properties: the associated suspicious activity report or SAR number, the name and ID of the bank submitting the SAR, the name, ID and country of the bank that sent the money, the name, ID and country of the bank that received the money, the number of sub-transactions, and the total amount of the transactions. Now, imagine you have to answer some complex question like which banks and countries are involved in the largest transaction set reported by the Deutsche Bank? Or what are the banks involved in transactions between the US and China? How much have they transacted? And how many SARs and how many banks made report on those transactions? For each of these questions, the analyst will need to run multiple queries. A basic user would typically use Excel filters and pivot tables to break down the query. A more advanced data scientist will use tools like Python or R to run those queries. Take the first question. First, we need to identify which SAR filled by Deutsche Bank have the most or the largest transaction. Once we have the SAR number, we then need to retrieve all the relevant transactions associated with it, and then break down the banks involved with each. Depending on the proficiency of the analyst, answering this question may take anywhere between 20 minutes to an hour. By integrating the data stored in this spreadsheet into reKnowledge, we can reduce the time it takes to find the answer to a matter of minutes. But before going into the querying itself, let me just explain what we did to map and integrate this data into reKnowledge. Like any integration exercise we do for our client, we first decide on how to organize the knowledge at hand. We start by defining the relevant node classes. In this case, we create a node class for the suspicious activity report, the bank, the countries, and the transaction. We also define the attribute information we want to capture for each of those node classes. For instance, for the transaction node class, we created attribute to store the start and end date, as well as information about the number and amount of transaction. Next, we define the connection we want to create. Here are all the connection types we've created for this project. Finally, like for the node, we map the attribute information we want to capture. Here, we've duplicated the transaction attribute and added them to the sent money to connection. This way, we can quickly query this particular information from different angles, but more on that later. Once we agreed on the information architecture, we developed a Python script to turn the spreadsheet into the relevant nodes, connection, and properties information. And we uploaded everything into reKnowledge. Now that the data is in reKnowledge, I can use our advanced search tool to build up my queries. So, let's answer the question we saw earlier. We start with the Deutsche Bank example. I start by asking the system to show me all the transactions associated with the SARs that were submitted by Deutsche Bank. This generates a lot of information. All in all, we have 71 SAR nodes and 188 transaction nodes on the canvas. While we can already identify some clusters of activities, to make more sense of the transaction information, I customized the visualization of the node based on the amount of of the transactions. And immediately we can see that we have one large clusters of very large transaction. So let's focus on that. I quickly remove all the irrelevant nodes so that I can focus on my cluster of interest. Next, I use the wheel tool to ask to see all the banks connected to those transactions. In addition to Deutsche Bank, which reported the SAR, we have 4 other banks that are associated with all of these transactions. Looking at the connection between the bank and transaction, I can see that the banks are either sender of or recipient of the transaction node. So I go to my visualization customization tool and I can customize each connection to visually differentiate them. At this point, I've also removed the SAR node because I don't need it anymore. I also unpin all the transactions so that they automatically reorganize themselves in the most optimum path. Once I've reorganized my canvas, I can clearly see that each pair of banks have been working separately. Finally, I use the mouse wheel to find out the location of each of the banks. In this case, banks were either located in Latvia or the Netherlands. One insight that immediately jumps out of this example is the circular nature of the graph. Money is sent from one bank in Latvia to one in the Netherlands, while in the other case, all the money flows from the Netherlands to Latvia. Now, there are no analytical insights to gather from this, because we don't know which clients are associated with each bank and transaction. However, given that all these transactions have been filled under the same SAR, it is fair to assume that there are some connection between all of them. But really, the point I'm making here is the ease with which one can find complex insight quickly and intuitively. First, I use the advanced search tool to find my starting data. Then, using the visualization and mouse wheel, I further my investigation until I was able to answer the initial question. And I did all of this without technical skills and in a matter of minutes. Let's look at the second question about transaction between the US and China. We want to know which banks are involved, how many and how big the transactions were between those banks, and what SARs are associated with them and which bank filled those SARs. So that's a lot of questions we need to answer, so let's get started. Here again, I start by using the advanced search tool and ask the system to show me all the connections between banks located in the US and those located in China. Here I use the connection because I don't know how much data will be returned, so I want to keep things simple. Luckily, the dataset is very manageable and I can quickly organize my canvas. At this stage, I've obviously identified the banks involved in the China-US transactions, and I have a fair idea of which are the biggest players. But I also want to know how many SAR are connected to all of these transactions, and the bank that reported them. So to find this out, I first remove the sent money to connection from my canvas and amend my query to bring the node transaction into visualization. Now that I have the transaction information in a node format, I can query those and ask to see all related SAR. And here they are. Finally, I can ask to see the banks that have reported on those SARs to complete the picture and answer all the questions. Here, it is worth noting that the banks that has flagged the most transaction between the US and China is the China Investment Corporation. And while they concern a lot of different banks, the reported transaction were the smallest of all suspicious US-China transactions. Here again, we have shown how easy reKnowledge makes answering complex questions. By combining our intuitive advanced search interface with the ability to interact and query specific pieces of information, analysts can see their insight and draw faster and better conclusions. If you want to find out more about how reKnowledge Enterprise can help your organization find new insight in your data, do get in touch with us.